In the name of Allah, the Compassionate and the Merciful. Hello guys, in this video we're going to have an example about the pushover analysis of 2D cantilever nonprismatic beam with force control in C programming. You see, let's see in this picture, you see that we have a cantilever beam with defining plastic hinge in here, and relation between moment rotation has been shown, and you see four kind of non-prismatic sections. You see section number 1 to 4. So in this example we use section number 1, and we're going to apply the load with the degree of freedom number 3, the incremental force, then applying incremental loads and trying to draw the pushover displacement base shear displacement curve. So let's see the C programming code. You see I defined many functions in here for inputting and outputting data, and for defining moment rotations, for calculating the matrix form relations between forces and stiffness forces. Here you see checking the data, outputting in HTML and Excel, and graphing in HTML, even outputting to the MATLAB file, even in text. You see, defining the stiffness matrix coefficient, you see in here. And if we run the code, and before we seeing the run the code, let's see the main very important function, the analysis function in here. You see we define the incremental forces, and in each step all forces and displacement is going to be calculated. We use the Newton-Raphson method for solving our converge problem and outputting our displacement, base shear and moments. All data are needed for outputting our forces and displacement in Excel, MATLAB, HTML and graph mode, you see, and at the end displaying the graph. After compile this code, the program is run in here. You see, let me show you. After running, you see input data as a length, flexural rigidity of I, it means the at the first, and J, it means that the end of the element. Conduct section is defined, which I told you. In here we use section 1, and when it says that the flexural rigidity I, it means the flexural rigidity of first of the section, and then at the end of the section the J. And let's see the other external shear applied, it is 0, moment is 0 at the external moment, and initial incremental force and degree of freedom number 3, it means that in here we have an incremental applying load, and ultimate absolute displacement is going to be checked if the displacement reached to this displacement, so analysis is going to be stopped, and maximum iterations tolerance of convergence is that, and number of increments is 3000. You see that plastic hinge properties is defined in here for defining our section moment rotation relation, nonlinearity behavior. Let's see. Analysis report is shown based on in each increment, iterations, incremental forces, rotations, and displacements of any nodes is going to be shown. And you see, after, let's see, yeah, you see that after 737 steps, the analysis is going to be end, and displacement at degree of freedom number 3 reach to the ultimate displacement, and then all data such as going to be exported into the Excel and MATLAB and even in HTML. And after that, the output base shear displacement graph is going to be shown. And I verified this example with an ABAQUS with the shell element and rectangular meshing the elements. You see, my programming in C, in modeling, which I modeled it in C, and ABAQUS answers is very near when it is the linear behavior, but when it goes to the nonlinear behavior, and in shell element we have post-buckling behavior when we indicate the nonlinearity behavior of geometrical nonlinearity. So the answer is going to be different because of the post-buckling behavior. But if we in ABAQUS we do not indicate the nonlinearity behavior of the, for example, I mean the geometrical nonlinearity of this shell element, so the answers is very, very near together. The blue lines goes there. So let's see. Modeling of ABAQUS. You see, I use shell elements with triangular meshing. You see, and you see that in here we have most stress in here, and in here we have less stress. Yeah. So you see that I modeled this cantilever beam in a C programming, and yeah, it is very hard to model it with very complex situations, but you know, I modeled it very simple and try to solve it and compare it with advanced programming in ABAQUS. So thanks guys, I'd be glad to know your opinion about my modeling. Bye.